The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark with SolidCAM. We'll be starting our 30-minute free training session today. With me, as always, is Kevin Rankel.
Hey, guys.
So today, we actually got a question following up on what I talked about yesterday, real briefly. And for Kevin's benefit, yesterday we were talking about negative X turning. And I mentioned yesterday how that's really more based on your tool mounting, and it's very simple. All it is just the tool mounting, and then everything else falls from that. And I mentioned kind of real briefly that in a right-angled head, it's the same idea. This can look really complex. If you ever see a right-angled head machine, it looks like it's kind of like a complex multi-axis kind of machine. But really, inside SolidCAM, all you're really doing is just setting up that index plane and then mounting your tool that way. And then everything is very simple after that. And what I have in front of you is a part file that we used in the training video on that, the tips and tricks video that you'll find on our YouTube channel related to right-angled head machining. First off, I know this was Brian's question, so he probably already knows what right-angled head machine is, but just for the benefit of everyone else, just in the questions panel, do you guys know what a right-angled head machine is? Have you seen one before, or do you want a little bit of a brief refresher on what that is?
Yeah, I'd probably just do a refresher. That way we know 100%, even for the people that are watching it later on.
Even for our own benefit, because we haven't looked at this in a while. So let's go into YouTube and right angle head. Let's see, right angle head for milling machine. Good old Haas. Okay, let's go and skip ahead to the actual. Does he actually use this thing? Okay, so there you go. So that's basically what a right-angled head is. You can see that this little attachment is attached to your spindle, and then because of the whole, obviously, like transmission system and all that, it actually is going to spin the end mill in that direction. So this is a regular 3D mill, but because of the right-angled head, we can actually program on the side there. And how we achieve that inside SolidCAM is using a modification to the VMID, modification to the post. So this is something you might want to get with your post guys on. You can see that the listing of this post is actually a 4th axis RAH, right-angled head. So this is not a 4th axis machine. This is a regular machine, but with the right-angled head attachment. If we take a look at the tool that I'm intending to use, I've actually defined it as a standard tool. So you see the z-axis is always always in the tool vector direction. But I've added this kind of STL holder to represent that attachment. So the way to program this, at least currently, at the time of this video and at the time of the original tips and tricks video, you had to do a modification to your post and then create an indexed plane very similar to what you would do with your 4th axis machines. So you can see now the Z is pointing in that direction. The true Z of this machine is still up. The spindle is still coming from up. But inside SolidCAM, we define it as this index plane so that we can get the tool path to work. So now you can see that the attachment comes down, the tool can come in and engage those holes. So right-angled head is just simply a modification, very similar to what you would get with your 3+1 machines. Your 3+1 machines are still 3D machines with some sort of attachment or a table or a trunnion or whatever it is you're adding to get that +1, that +2. So this is the same idea. The limitation, though, is that you can only now act in this direction. We're not, with this modification, you're not able to flip this guy around and then do the other side. So again, currently, now, if the post processors have updated themselves to be able to handle this a little better, then you can discuss with your post team the best way to actually assign your parts, assign your tools to get this done. And even further, a little secret behind the scenes thing, the future tool table will make this aspect a little easier as well. So if anyone has actually been able to see any of the webinars on looking forward inside SolidCAM, this will be a lot easier. Now, I don't know if I'm talking out of school. Kevin, you tell me if I shouldn't have said anything, but
no.
Tool table makes this much easier.
Yeah, and for everyone that is watching right now, On the 21st, which is next Tuesday, we are going to do a sneak peek at SolidCAM 2021 with this new tool table. So definitely
the
come check
synergy.
it out.
The internal SolidCAM tech support team synergy. I mentioned it. Kevin's going to do it. So good stuff. So how do you actually program with this? Well, kind of like we talked about yesterday with the negative X turning. Now that I have my tool mounted, I have my index plane. Now it's just simple 2D, 2.5D, even 3D toolpaths, because we're just talking about a tool mounted in a different direction, but the toolpath is the same. So for instance, with this profile toolpath, I just chose that one hole, similar to what I would normally do with 2.5D, just happens to be on that plane. The tool, I still selected it the same way. You can see here that it's still mounted that way because that's the Z in this plane, or in the tool picture. But again, just for reference, since Z is pointing that direction, we now have the tool like that. But everything about this is the same. The levels, technology, all of that is the same, so that when we take a look at the toolpath, it does that bit right there. And then likewise with the drill, I mounted the drill in that direction as well. I was able to drill all those holes. So right angle head is, again, kind of like we talked about yesterday. It looks a lot more complex, looks like there's a lot more going on, but it's simply just a matter of tool mounting and a little more on the post side as well. But once you get the post, you'll never really have to think about how to set this up. You'll just set it up with your index plane, and then you can do your right angled head. To do the other side, I would need the other index plane, and then I would have to define my tool in that direction as well with the STL and all that kind of stuff. But that's currently. Once next week rolls around and you can see the new tool table, Kevin can show you how there's different mounting abilities inside that tool table. It's going to be an innovation in our tool definitions. So any questions on this or anything related to this or the stuff from yesterday?
And some of the indexable or the right angle heads are adjustable. They do make some out on the market for this. And I haven't talked with the post team, but go ahead and open up the that drill operation for me, Mark. And you would still want your coordinate system pointed in the exact same direction as what Mark has right here, but in the miscellaneous parameters, we could put a G code in there to tell it, or whatever kind of code that that right angle head to index it or move it to the opposite end. So there is that option there for you guys as well. So basically turn your 3-axis machine into a 4-axis. They're not the most rigid out there. They're kind of more designed for drilling and tapping, but that option is there for you guys too.
Yep. Just a quick talk about this section right here. Miscellaneous parameters is where you'll find a lot of, like Kevin said, anything related to the post or additional parameters that don't really fall in the categories of levels, technology, or geometry. You'll find a lot of stuff gets popped in here that really doesn't have a category. It's kind of the, like it says, miscellaneous. And this is where stuff can be added for you, again, like Kevin just said, by the post team. So if there's any additional parameters that when you post out this particular toolpath, you need to know of in terms of angles or a whole bunch of stuff can be thrown in there. It's mainly just the post will actually ask the question of whatever parameter, and you'll get a little separate message that when you go to G-code this, it'll pop up asking that, or it'll read that from this this toolpath. So there's a lot of extra stuff that won't really be found in our training videos or our training manuals or anything like that. That could be added here that can really help out in terms of your programming. And an example of that, there's just so many that really we can't really pinpoint one that says, okay, here's a good example of it. It's just pretty much any additional extra parameter that that you've ever encountered. And this is a good way to kind of modify to your very specific applications. You can find a lot of really unique parameters that can be added to this list. So any questions on that, I think from yesterday, any questions, any new questions for today? And if not, I do have a topic that I mentioned yesterday that now that we have Kevin on the line, we can kind of flush that out a little bit. But does anyone have any questions on anything of today? Just give some time for the, nobody, everybody knows everything about SolidCAM. what are we doing here? Okay, so what I mentioned yesterday was there's a lot of times where your calculations, your simulations, anything that your SolidCAM is trying to do for you, but there's just some kind of slowdown for whatever reason. And there could be many reasons, but there's a lot of things we can do to streamline your computer. There's a lot of things we can do to streamline your SolidWorks, your SolidCAM. And that's kind of what I was asking yesterday, if you guys have ever encountered those sort of situations. But we have had customers kind of questioning, okay, well, what's a way we can kind of get this to go a little faster? I know we've done, I believe it was a KevCam on I forget what you called it, but there was a topic where you basically went through all the different parameters, all the different setup options, anything you could really do to streamline and kind of speed up what you're doing. I think you even called it something like accelerate your programming.
Yeah.
So if no one has any questions, I was just going to see if we can probe Kevin's mind on those sort of things real quick, what we could cover in today's session and even tomorrow's session if we need to show some more examples.
So I guess the first thing that kind of tops to my mind, just kind of thinking out of the blue here, is go ahead and open up your local settings. Now, everybody has this option in there, but once it gets popped up here. Okay, so now if we go under the updated stock calculation, if you guys are running across in simulation and it is taking forever to load it, even your updated stock is taking a while to load it, go ahead and click on the Solid Verify tab. And that number right there that is highlighted, this is the facet tolerance accuracy of the Solid Verify. Now we could make this 4 inches if we wanted to, and the simulation would go through blazing fast. It's not going to look pretty at all because the facets are 4 inches, but it will get through a calculation really quickly. The one thing I want to stress though is with this tool facet tolerance right here, this does not affect the G code whatsoever. So just keep that in mind. This is just for Solid Verify as well as the updated stock that you guys can turn on that check mark in the tree. So that's one thing. If you guys are running tight tolerance parts, then definitely crank it down. But what I used to do at my old job is leave that open till about 5 thou. Get everything run through, get that entire part programmed all the way through. And as my last final check, what I would do is I would turn that tolerance. I mean, we're talking if I had a tolerances of plus or minus, 0.2 in there, then to make sure I machined off all the components and got everything. Then my last thing when I was completely done programming is I would come in here, put this at 1/10 and play it through and go get a cup of coffee or whatever, because depends on the part size. It will take a little bit of time, but at least you're not doing that for every single operation. So if you guys wait until the end to crank down that tolerance, then you're not doing, usually after every operation that you guys create, or at least I did, I would Solid Verify just to make sure that's what I'm looking for, and then go on to the next one, go on to the next one. So all that time definitely does save up right there.
Yeah, so it's fair to say you probably would not crank this or make this a finer facet unless you're looking at your finishing toolpaths. Whereas
Correct.
with your roughing, you want to just see that it doesn't gouge to a certain point, but it's the finer details that you're looking for. So I agree with Kevin. I would run it just to see if everything's in the right spot, kind of no major gouges, because roughing is just going to be more of a major gouge than a really fine detail. And then the final toolpath or the final toolpaths themselves that are responsible for finishing, then make this a finer tolerance, and then get up, go get your cup of coffee, and come back and look at your nice picture. But the finer you make this number, the longer it'll take to calculate, exactly like Kevin said. And this is why we would bring it up, because a lot of times, you can see mine's defaulted to that 4/10. I don't have too much of an issue with 4/10, but there are times where it's a much larger file, like literally the file itself is just on the scale of feet rather than inches. And some customer files are that large, oftentimes you don't want to run this at even that close, even for finishing, because that's just going to take forever to just simulate, just because of the scale of it. So this is one number definitely that you would want to look at to minimize any kind of slowdown. You'll find that if you try and open up your Solid Verify and it's just taking forever to open, it's because of this number. So you want to take a look at this number before you go into your Solid Verify.
Yep. Now, one other thing I really do like to do as well as go ahead and cancel out of here, Mark. And when you guys go into a simulation and you simulate a part, and let's say, yeah, go ahead and simulate this, Mark. And let's say, do you have a machine sim for this one?
No. Nope.
Okay. So for the guys that do have machine sim, it takes a little while to load up, but now, or even do a Solid Verify and go ahead and play that through. So now Mark plays it through, it looks good, and then, all right, he's done with the simulation. He's happy with the way it looks, and then he's going to come back and go on to the next one. But when he does save and calculate and simulate, it's going to default back to the Solid Verify, which it may take a little while to load, or the machine sim. So in the actual settings, so Mark doesn't have his set up this way, but some people do, and they don't realize it. So every time Mark launches a simulation currently, it is always going to be defaulted to HostCAD. Now there is that option for the simulation, so it uses HostCAD versus remember last simulation. So like I said, some of you guys like to just run Solid Verify all the time, and that's great. But if you're just looking to do a quick wireframe, that way you're not taking that time to load up. This will also save you some additional time when you're doing your calculations. Perfect. Yep. Any questions on that, guys? Okay, one other one. Oh, I just seen one coming in there. Is there a way to speed up the refresh in SolidWorks? Upgrade 2020 now. Every time the mouse goes over the model, it wants to recognize. Yes. So yeah. Go ahead and show the performance SolidWorks options. Sorry. Now, Scott, I want you to do this on yours as well, because usually what you're seeing there is something telling me that your graphics card is not working. So if you go over to the system options and click on performance, and at the very bottom, you'll see where it says use software OpenGL. If this is checked, and you'll have, if it's like right now, it's grayed out because Mark has a part open. But if that is checked, what it's doing is it's using the internal, the Intel graphics card versus your NVIDIA card. So that's where we will go in there and check to see if your graphics card is working correctly.
So just as a review, you click on the gear symbol, go to the system options, performance, and mine is still grayed out.
Yep.
But
if that one is checked there, then you're not even pulling from your graphics card. Now, another way of checking that, let's see, that's what I'm using, and it would not show the model without that checked. Okay. So, Scott, are you running a graphics card on your computer, an actual dedicated graphics card? And a good way to tell is just right-click anywhere on your screen and click on NVIDIA Control Panel is usually what everybody's running.
So that's what I basically did. I don't know if you guys saw it, but I right-clicked on my desktop, just my background here, went to NVIDIA Control Panel, and it should be popping up soon. We've got GoToMeeting open. I'm actually translating a video of a training session I did a second ago, so it might actually be kind of really lagging down my computer. But like Kevin said, if you've got a graphics card, you want to take a look at the graphics card menu, and then there's some stuff you can actually streamline in there as well. I'm not sure if that's where you were going,
yep.
Kevin, but I
think
that's
exactly where I'm going.
So just open up on the other screen. I'll just bring it over once it's There it is. Perfect. Okay, so bring it over. There it is.
Okay, so everybody, you guys will see this in there. Now, when you right click on your desktop and you don't see this NVIDIA control panel, that means your graphics card is not working. And to update that, wait 2 seconds and we'll show you how to do that. So if you do get this to pop up, it will most likely be set on base profile. Do you want to show them where that base profile is? So at the very top, it's going to be at a base profile. This is like a base tune for a car that, I don't know.
All season tires.
Yeah, there you go. So what we're doing is if you hit that drop down and go all the way down to the very bottom, and it's dynamic streaming. This is a setting where it turns off some stuff and turns on some other stuff to really optimize the graphics card for your SolidWorks as well as your SolidCAM. And then you can hit apply. And once that's done, we can exit out of there. And where was I going with this? I was going to show how to upgrade the driver.
Yeah, I think that's where you were going with.
So what you guys can do is on the Cortana search, you can type in Device Manager.
So you can't see it because I have it on my other screen, but in the bottom left corner of your screen next to the Windows icon, there's a little search bar. You just type in Device Manager, and then you open that up like so.
And you'll see this. So then from right here, you'll want to click the little arrow out for display adapter. And we can see that Mark is using the Quadro M1000M. And from right here, you can click on Properties and go ahead and click on Driver. And so Mark is running a driver. Now this gets a little tricky because the way Windows does it versus NVIDIA does it. So you take the last 5 digits of that number. So Mark is running driver 431.70. Yep. Now, if he goes over to the website to nvidia.com, we can actually do a search and see if that is the latest driver. Nope. You're gonna type in M1000M or just click on drivers. Alt NVIDIA. And product type is going to be Quadro. And it's going to be a Quadro series, which is the product series. Yep. And then we can go down to find the M1000M. Which I am not seeing.
Yeah, I don't see it.
Okay, so now we can do a search for M1000M.
Welcome back to SolidCAM Live. Okay, so let's go back to M1000M.
All right, and maybe type in M1000M driver. And usually when you guys do the drivers, usually it shows up in there. So you guys can just basically click on the driver and find the latest driver in there for that one. And I guess for training purposes, let's go ahead and go back to drivers. Yep. And go ahead and do the Quadro series. And let's do the P1000 or P5000. right there. And go ahead and click search. And so what this will tell us up in the version at the top, so that driver is, no, one more up, is 451.48. So it would definitely be a newer driver for Mark to download. So they used to have this on the SolidWorks site, and you can still access it from the SolidWorks site, but all it does is once you get done filling out the information in there, it will automatically default over to the NVIDIA card site now. So I found it's just easier to come over here and do it that way. Any questions on the failed driver event there?
There should be a way to find at least the version or the type of driver that I'm looking for. Maybe just not on that direct search icon there,
Yep.
but someone has the driver somewhere, even if it's archived somewhere. So if you can't find that driver like we just did for me, I would probably just see if I could do it in another way. I'd do a search of like a reseller's website or something like that.
Yep.
But that's one way to kind of streamline your graphics if you have the proper driver. Otherwise, you're using the OpenGL, which might be a little slower, but you do what you got to do, basically.
Yep.
Okay. So we are at the end.
If you don't have a graphics card, you will be forced to run that software OpenGL. And if you guys are running a laptop, you really can't add a graphics card at that point. It would, if you bought your computer without a graphics card, it probably isn't the most efficient computer or high-end computer for the job. But if you guys are running a tower, those graphics cards can be added in there. But,
oh, you mean like physically adding the
yep, physically
hardware
in there. Yep. And then I do have a bunch more, but we will continue on that for tomorrow. So.
Yep. Yeah. So for today, if you have any further questions, Kevin's going to put my email in the chat section, so you can use that email to contact us with your questions, comments, suggestions. You can use that email as well to get into your own personalized training session. So just let me know the day and time that you're free, and we can schedule the training session based on your schedule. We can do personalized training there over GoToMeeting with a phone call, so you can talk to me live, ask questions live. If you know anybody that can benefit from SolidCAM, give them our contact info or get them in contact with us. And if they go into a demo, you get that $100 gift card. If it goes to sale, you get 20% of that sale. So that's probably a good chunk of money just for letting us know someone who's interested in getting SolidCAM. We will continue this every day for now until the end of the month at 2 p.m. Eastern time. So stay tuned tomorrow. We'll probably do this topic tomorrow. Kevin will have more suggestions. I'm going to put Kevin on the spot to give more info on that.
And Scott's saying, you know, I guess it's time to upgrade laptops. So tomorrow, what I will do is the exact same thing is when I need to get a new computer or Mark needs to get a new computer is I'll show you the process that we go through, the website that we go through, that we've had very good luck with, and things to look for in a laptop and a desktop too for you. So.
Excellent. Okay, so we'll look forward to that tomorrow at 2 p.m. Until then, stay safe, keep your family safe, stay busy, and we'll talk to you guys tomorrow.
All right, see you guys.